Or lesson 60, is about geometric solids, prisms, and cylinders. So I brought some tools to class, or to our video class, and we'll start out with some basics. But the first thing they wanted us to remember is that back in lesson 15 we defined geometric solid as a geometric figure that had 3D or 3 dimensions. Okay, some example of geometric solids are what I have here. Okay, a right triangular prism. Okay, that's what this is, a right triangular prism. So it stands upright perfectly. Okay, it doesn't lean at an angle. All right, a right circular cylinder. Okay, so this was, and we've learned how to do surface area of these. Okay, that's what they look like. Okay, the next thing would be a regular square pyramid. Now mine sometimes like to fall apart because we have something in there that we're going to look at. Okay, a right, meaning straight up and down, it doesn't lean, regular square pyramid, which means it's all the angles are the same and all the sides are equal. Okay, a cone, and the way I always think of that is put some ice cream in there. We got our ice cream cone. So we have a right circular cone. Okay, and then our sphere, which is a ball. Okay, a prism is a geometric solid where two faces are identical and parallel polygons. Okay, so we'll go back to this. This is a prism. Okay, I'm going to pull out 2 other prisms. Here's a prism. So let me take these off the table here, out of the way. Okay, and put out my prisms. All right, let's see if you can see what makes them all prisms. There's a prism. Here is a prism, not prison. You might feel like you're in prison by now because it's been several lessons. All right, so these are all perfect, upright, although not all prisms are upright. Some of them can lean. I have no, oh, here's another one. I have no examples of leaning prisms, but if you look in your book on page 243, they will show you some. Everything I have are right. Okay. All right, so like this is a right prism, and they all have some vocabulary to them. And let's go ahead and pick this one. All right, and I'm going to count. Let's see. I believe this is a hexagon. Do we have six sides there? Yep. Okay, so it has a base. The base is the top. Here's the base, okay? And so it always has 2 bases. Okay, in fact, if I take your base off, this is what your base looks like without the hole. Okay, the hole's there just for me to be able to take it off. So the base is actually 2-dimensional. All right. Then they all have a lateral edge. So that would just be any long point. A lateral edge is a line segment, okay? And the altitude is the height, okay? We also call that an altitude. So it's how long, actually, is the lateral edge in a right prism, not always in a not right prism. Okay, and then these pieces. Okay, this was a base, this was a base. All the other faces are called lateral faces. Okay, so anything that has to do with the body around here is called lateral. Okay, the lateral surface. Okay, or lateral face. Okay, so let's look at these are all the other. This is a right rectangular prism. Which means it's a rectangle. The bases are rectangles. Okay, and then it has a height, so that makes it a right rectangular prism. This is a right triangular prism. It's actually a regular right triangular prism because it's an equilateral triangle. All right, so it has two triangular bases and then rectangular faces. Okay, so if you look straight on this way, it's a triangle. If you look straight on that way, rectangle, okay? And there's three rectangles. So again, if we're doing surface area, you get the surface area, you get the area of this triangle, double it, and then three rectangles. Okay, 1, 2, and 3, and then you've got all your areas. All right. I think I covered all the vocabulary, and we're going to talk about volume of a prism. Okay, so I'm going to take, I don't know, let's take this one. And the trick to finding the volume of this, and then I'm going to turn to our notes here in a minute. The trick to finding the volume is like how much room is inside, right? The trick to finding the volume is actually easier than surface area. We will do surface area next. But the volume is the area of the base. So we find out the area of this hexagon here. Let's see if you can see that. You see that hexagon? Get the area of that and multiply the area of a base times the height. Okay, so area of this thing times the height. All right. So I'm going to move my stuff over, and we're going to look at that on paper. All right. Okay, and then back to this. If I wanted to find the volume of this, get the area of that triangle and multiply it times the height, whatever this segment is. Okay, so let's see. I believe this is our notes. Let's see how well we are. Oh, good. It's actually in focus. All right. So I just said read over the first two sections. Go ahead and look at that, but that's what I just did. I kind of went through vocabulary with you. All right. The volume of prisms. Here a minute. The volume of prisms and cylinders is volume of the base times the height. Now, it's a big B because it means the area of the base times the height. Big B is area of the base. Little h means the height of the solid. Okay, so if you look in our book on page 244, I don't really have a pentagonal prism to show you. All I have is the hexagonal one. Okay, so kind of similar. They went ahead and said the base of the prism is 28 centimeters squared. So they just, let's say they said the base of this was 28 centimeters squared. So they just did a lot of work for us and told us what the area of this piece is. Okay. And then they also said the length of a lateral edge is 10 centimeters, which actually is the height because it's it stands up straight. Okay. So it's a right prism. So if we're going to find the volume, we just need to do the area of the big base times the height. Okay, so well, they told us the area, or not the big base. The big B means the area of the base, all right? And they just told us 28 centimeters squared, and it's 10 centimeters high. So to find the volume, we do 28 times 10, and we don't need to do any extra work because when you multiply by 10, you just add a 0. And since it's volume, it's centimeters cubed, okay? So that's how we do that first example. Then I told you to read about lateral surface area. I'm going to use a little visual for you that is nice. Okay, I'm going to use my, they keep doing hexagons, but I'm going to use, or pentagons. I'm going to use a hexagon and talk about surface area. Inside each of my figures has the same figure, but we can unfold it. Okay, so we can look at, we're talking about surface area. We want the area of every side or face. And if we have a hexagon, that means we've got 6 rectangles around. In fact, I'll just take it apart. Okay, see if you can see this. Okay, there it is pulled apart. This is called a net when you unfold all the parts to a 3-dimensional solid, okay, or a geometric solid. All right, notice we have the two bases, the top and the bottom, and those are hexagons. And then all the lateral faces happen to be rectangles. Now mine is regular, so all these happen to be the same. But if you notice, if we measured all the way around, that would be one side of a very large rectangle. Multiply it by the height. And that's where we got the stuff that we've done in the past. It's nice to be able to actually take one of these and unfold it. Okay, so the lateral surface area is harder, okay, because it takes a lot more calculating. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8 pieces, 8 areas that we need to add up. Okay, and back when we did it before, we talked about the perimeter of the base. Okay, so I put my base back together. All right, the perimeter is the area around, or not, sorry, the length around it. So if we pull it apart, there's the perimeter of the base from fingertip to fingertip. You see that? That's my perimeter unfolded. Okay, and I will do that with one other piece that I might have. Okay, one of these. Oh, I don't have the net for that. That's a bummer. I'll have to make one. I have a net for a box. Okay. So again, we have perimeter. It turns out to be a very long piece. Okay. So in the example 6, example 2, sorry, we have to find the lateral surface area of that figure, and what they gave us looks like is a regular pentagon, okay, and it has one side is 8 and the height is 15. So that means we have 5 little rectangles with the width of it 8. And if you look in your book, or I'll even just show you again, we have 8, 8, 8. Each little face had an 8. Okay, so that means the perimeter of the whole thing is 8 times 5. Happens to be 40. Okay, oh, and there it is. Perimeter of the base. So what we want to do is find the lateral surface area, because that's what they're asking us to find, lateral surface area, perimeter of base times the height. So we found out the perimeter of the base is 40 and the height is 8. Okay, so if we wanted to find the, put that together, oh, what am I saying? The height is not 8. Sorry, it was 8 times 5, which is where we got the 40, okay? Times the height was 15, okay? You multiply those together, and we get 600 meters squared. Now, remember, we're dealing with area, so we're squared, all right? And the rest is practice. I know that was a weird lesson with the visuals of the, but I might even take these manipulatives and give them to Jordan to take to you guys to kind of play with. But being able to play with those nets helps a lot. Or if you could take a piece of paper and carve it, or not carve it, cut it out and fold it up and make the shell of one of these figures, it will help you a lot kind of to visualize the surface area, which has in our class been the hardest thing so far. I've seen the most mistakes on surface area. Okay. And that will be it. This was just lateral surface area. It's not our total surface area, just to remind you, because we don't have the area of the hexagons in there. This was just the lateral surface area, which was just the area of these side pieces without the top and bottom. Just that one long rectangle. That's what they asked us to do in that example. So it was just this rectangle without the bases. 2 practice problems. They shouldn't be too difficult. Just follow the examples that we did. All right.